Hi there, and welcome to the very first video of the packed course on deploying AngularJS. In this course, we will learn how to deploy our application in a production environment. This includes creating a build system to get our assets ready for production, and also actually deploying it. This course assumes a working knowledge of JavaScript and AngularJS, and the basics of Unix and terminal to get you started. We also assume you're using a sane, evergreen browser such as Chrome, Firefox, or any other modern browser. For this project, we've chosen to deploy to Heroku. However, we first need to actually build our application before we can deploy it. So let's get started straight away by setting up our environment. In this first video, we'll go over the technical requirements for the course. First, we'll take a look at exactly which applications we'll need for our environment. Then we'll install some global node modules to make our life a little easier. And finally, we're going to add the Heroku tool belt so that we can use it to deploy our application when it's finished. So the first thing we're going to have to do here is install Node.js, which you can just find on nodejs.org and click on the big install button. There's an easy install there for Windows, Mac, and also Linux. Node.js is a platform built on Chrome's JavaScript runtime. We're going to use it to leverage existing tools for our build system. npm, which is a node module, is installed by default. It's going to allow us to easily download node modules from the web. When Node.js is installed, we're going to go ahead and add our first global node module to our system as well. The first module we're going to install is Bower, which, like it says over here, is a package manager for the web. It's going to allow us to manage our front-end dependencies in a really nice and easy way. By front-end dependencies, we mean things like JavaScript files, CSS files, and so on. Some well-known examples for these packages are Bootstrap, Foundation, jQuery, and also, obviously, AngularJS. So we'll go ahead and open up a terminal, type sudo npm install -g bower. Alright, there we go. This installs the Bower module for us globally, which is what the -g flag is for. This way we can use a node module anywhere in our system. Let's take a look at Bower's version by typing bower-v to make sure that it works. Alright, perfect. So the next module we're going to install is GulpJS, which is going to handle our entire build system. For example, concatenating files, watching them, reloading on change, and so on. So let's go ahead and go back to terminal. Same command, but this time install Gulp instead. Okay. Now, keep in mind that we don't have to install them globally, but we do it because it makes our life a lot easier. For example, we can now globally use the Bower command and also the Gulp command. And finally, we're going to install Heroku tool belt, which isn't a node module, but you can just download the installer here on toolbelt.heroku.com for basically any platform. It's going to allow us to interact with Heroku from the terminal. For example, we can log in and then create a Heroku application. We can also deploy to Heroku from inside the terminal, which makes it a lot easier to work with Heroku. After installing the Heroku tool belt, it should look like this. You should have the Heroku command inside terminal, which we will use at the end of the course to deploy our actual application. So what we've done so far is installing all of the required applications that we need for our environment. We've set up some global node modules, which is going to make our life a lot easier for running Bower and Gulp commands. And finally, we've also added the Heroku tool belt, which we'll use to deploy to Heroku. In the next video, we'll be scaffolding our project to get a good architecture before we actually start developing the application. This is the second video on deploying AngularJS, the first section called Setting Up. In this video, we'll be scaffolding our project. What that means is we're going to take a look at initializing both the manifest for Bower as well as npm to keep track of all our dependencies. We're also going to add a basic Gulp task to illustrate how Gulp works. Let's go ahead and create a directory for our project and open it in your preferred editor or IDE. So here we are. The first thing we're going to do is add a bower.json file to our project, which is going to be a manifest for our front-end dependencies. We'll do that by bringing up the terminal and running the bower init command inside our project. The name is fine, the default options are usually okay. And here we go. We should have a bower.json file. All the dependencies we install and save using Bower are saved to this file, so we can easily install dependencies in another location if needed, for example, on our deployment server. Now, let's do the same for our node dependencies. It's pretty much the same command, npm init. It also works the same way by suggesting default options. We'll use those for now. Generate our file, and here we go. We have a package.json file, which is going to keep track of our npm dependencies. In this project, those are going to be our build system dependencies like Gulp, for example. Speaking of which, let's add Gulp now by saving the module to the dependencies inside package.json. Type npm install --save gulp. This will save it to the dependencies in the package.json file, allowing us to install the project's dependencies based on the file's contents. Sort of like a recipe which lists the ingredients we need to cook our dish. Also, we're going to add a gitignore file to our project. As you can see, there is a node modules folder now. We don't really want to commit those to Git, for example. So I'm just going to ignore both the npm and also the Bower folder. Gulp is a build system, a lot like Grunt. However, Gulp is a streaming build system, which means that there are no intermediate files generated while building, increasing the speed at which your project is built. Compared to Grunt, Gulp uses code instead to configure the tasks. Lastly, Gulp plugins are usually really small and laser focused, making it easy to understand which part is responsible for what in our build system. We're going to add a Gulp file to our project and create a small task to make sure that it actually works. Let's go ahead and create a gulp file.js inside the root of the project. We're going to require Gulp and we'll just create a task. Let's call it hello and say hello from Gulp. There we go. Now we can run this hello task inside our terminal in the project by using the gulp command and then the task's name. In this case, that would be gulp hello. And there we go. It says hello from Gulp, just as expected. Alright, so the next thing we're going to do is add a source directory which is going to house all of our application code. We'll just start by adding a small HTML file with the title and just some body text as well. Let's say packed and hello deploying AngularJS. That'll do for now. Now we'll also add a small test directory as well. We're not going to use it yet, but let's just make sure it's there already. Let's wrap things up with a quick recap. What we've done in this video is adding the Bower and npm manifests so that we can save our dependencies. We've added a basic file structure using the source directory and also the test one. And we've also added a basic gulp task to verify that gulp works as intended. In the next video, we'll be taking a look at a sneak peek of the final application so that you know what we're going to build. This is the final video of the first section of deploying AngularJS. In this video, we're going to be taking a look at a sneak peek of the final application. The application is basically a sort of animal arena. In that arena, you have animals that you choose to play as or fight against. Every animal has a specific set of statistics. Those stats will also determine which animal will be victorious. There's the terrain as well, which influences the animal's score too. For example, a fish would do pretty horrible fighting on land. Now for a more concrete example, let's go ahead and play a match. It's going to generate a matchup for us. There we go. We have to play against the anaconda in the Namib Desert. We're going to pick a rhino here. Let's fight the match, and it looks like we won. One thing to note is that the application you see here has added styling and markup. This is not part of the course. We're going to be working with an application with no styling involved at all, and as such, our working copy is going to look a lot uglier than the one you're seeing right now. The reason for that is that this course is focusing solely on the JavaScript and deployment process, and not on adding markup and SASS. This allows us to focus on the things that this course is really made for. However, you can find all the styling for this final preview, including the images, in the completed code bundle or in the GitHub repository. In the next video, we'll be code testing with Karma and JSHint to make sure our code is reliable. This is the first video of section 2 on preparing our development environment. In this video, we're going to set up Karma to run our tests and JSHint to lint our codebase for any code style errors. When you start developing an application, it's always a good idea to set up an ideal workflow beforehand. We will do just that by making sure our code works as intended using unit tests, and by verifying that we write clean code that adheres to conventions using JSHint. The first thing we're going to do is add Karma to our local project in the Node Modules folder, and also install the Karma command line interface globally, which is going to expose the Karma command in our terminal. Let's install it locally first. Type npm install -- save karma, and it's going to persist it to our package.json file. And here it is. Karma is a task runner that runs our tests on a set of browsers. These browsers can either be regular browsers like Chrome or Firefox, or something called a headless web browser, which is what PhantomJS is. It's a browser without a graphical interface and is used for various reasons. We're going to use it for running our tests. We'll also install the Karma command line interface globally. This is going to allow us to use the Karma command in the terminal. First thing we need to do is make a Karma configuration file, which is done through Karma init, which we'll do in terminal now. I actually prefer to use Mocha instead of Jasmine for my testing framework, which is a personal preference, so I'm going to select that instead of Jasmine. We won't be using require.js. Like I mentioned earlier, we're going to use PhantomJS as our browser for running Karma tests. Let's add our source files and also our test files. Now it's going to give us a warning that there are no files yet, but that's fine. We're going to add some files later on anyway. We're not going to need to exclude any files for now, and we also don't need to run any tests on change. There's one thing we have to do inside our Karma configuration file, well, two things actually. The first thing is to force it to use a single run, which is going to run the tests and then exit the process completely. And the next thing I do, which again is personal preference, I'm going to add chai as a testing framework as well, which exposes a should syntax for testing, which you'll see when we start writing tests. Now, all we have to do is save all this stuff, so type npm install -- save, karma mocha, karma chai, and karma phantomjs launcher. It's going to save it to our package.json file. The next thing we're going to do is create a little test to make sure that it actually works. Let's call it sanity or something. We're going to create a new file called sanity inside the test directory. Let's create a sanity suite and add a test saying it should work properly or something. Let's say true should equal true. That should obviously work. We're going to run our tests using the karma start command, and we also have to give it the path to our karma configuration file. I'm going to start it right now. And there we go. Executed 1 of 1, and obviously it's a success. We'll also add a Gulp task to run our tests instead of having to do it manually in terminal. We can remove the placeholder task since we don't really need it anymore, and we'll add a new task called test. Now, Karma is sort of special because you don't need a Gulp plugin wrapper around your Karma to use it in your Gulp file, so you can just use the Karma API inside of your Gulp file straight away. So we're going to require Karma here. Let's start it, pass in the configuration file, which is called karma.conf.js, and force it to single run anyway, just to be safe. We're going to pass in the done callback because it's an asynchronous task. Let's see if it works. Let's run gulp test in our terminal, and there we go. It does the same thing as before, just like it should. The next thing we're going to do is add JSHint to our project, which will allow us to lint our code for any code style mistakes and so on. So the first thing we're going to do again is add it to our dependencies. We're going to install gulp-jshint and also jshint-stylish. Stylish is another reporter for JSHint, which is going to make things a little prettier, which is always nice. We're going to require all the needed modules, and we'll create a task for it. Let's call it JSHint. We're going to return the gulp stream, and we're just going to lint our source files. There's no real need to lint your test files as well. I'm going to pipe in JSHint and also afterwards the JSHint stylish reporter. The last thing we need to do to get JSHint up and running is to pass it options to know what it should lint for. We're going to create a .jshint.rc file in the root of our project. I've got a live template for this with a couple of sane default options, max length, indentation, semicolons, and so on. You can look up all the options on the JSHint website, or you can just use the ones I'm using right now. Let's find out if JSHint actually works like it should. Let's create a source file in our source directory. Let's call it JSHint check, for example. We're going to log something, see if it passes any errors, which it shouldn't. There we go, it's all clean. Now let's remove a semicolon and see what it does. Save the file and then run the task again. And there we go, it says it's missing a semicolon, which is obviously what it should do. I've chosen not to add this task to automatically run on file changes. I usually just run it once in a while to see if my code style is still up to snuff, and then make changes if needed. So go ahead and run the JSHint task a couple of times during the progression of this course to make sure that our code style adheres to the conventions we've set up. Alright, great. Now we have part of our development environment set up like we want it to be, and now we can get on with developing code with confidence. We can test our code and maintain a consistent code style as well thanks to using JSHint. In this video lesson, we've set up our development environment so that we can get started working on the actual code. In the next video, we'll build our BrowserSync and SASS workflow so we can serve our application and easily modify styles. Welcome to the second video of section 2 on preparing our development environment. In this video, we're going to set up BrowserSync to serve our application and integrate automated SASS compilation to make styling our application a lot easier. Let's start by serving our application using BrowserSync. BrowserSync has two purposes. First of all, it's going to serve our application so that we can view it in the browser. And the second is that it adds live reload integration to that server. This way we can automatically reload our application if we make any HTML or JavaScript changes, or even refresh the CSS without even reloading the page at all. After adding BrowserSync, we'll integrate SASS compilation to have a maintainable and well-architectured CSS codebase. We'll compile our SASS down to regular CSS using Gulp, and then let BrowserSync know it has to reload the CSS in the browser. Let's start by adding the BrowserSync node module to our dependencies. Just like we did last time, we're going to use npm to install it, save it to your dependencies. Now that we've added BrowserSync to our node modules, we're going to add a task for it in our Gulp file. We'll just open up our Gulp file and then create a new task. Let's call it serve. In this task, we're going to start our BrowserSync server and then pass in the root of the directory that we're going to serve. In this case, that's the source directory we created in section 1. Alright, let's take it for a spin. In the terminal, run the Gulp task we just added by typing gulp serve. You'll notice that BrowserSync also makes our life a lot easier since it's going to open the URL in your default browser, which in my case is Chrome. The next thing we'll do is add SASS compilation. Naturally, like always, we'll first have to install the node module, which is Gulp SASS in this case, so use npm to save it to your dependencies. Just like we did with BrowserSync, we're going to add a Gulp task to our Gulp file so that we can compile the SASS. Let's call the task SASS for now. We're going to use the styles in our source directory as input files, pipe them into the SASS plugin, and then finally save them to the same styles folder. This is going to generate a single compiled CSS file in the styles folder. We'll just add some basic SASS to our project and compile it to verify that it's going to work as intended. The first thing we'll do is create an app.scss file in the source styles directory. We'll use the variable feature in SASS to make sure that it works. We're going to declare a variable for our background color. Let's call it background color. We're going to apply this color to the background color property of the body element. Next, we're going to run the Gulp SASS task to compile our vanilla CSS file. As you can see here, the CSS compiled successfully. Now all we need to do is add the CSS reference to our HTML. Let's switch over to our browser to verify, and there we go. The background color has changed just like we wanted. Now, all this build stuff is pretty cool, but having to manually run our tasks every time our files change is going to get pretty boring after a while. This is where Gulp's watcher comes in. We're going to add 3 watchers, one for our HTML, one for the JavaScript, and one for the SASS files. The first thing we're going to do is add a separate task that just triggers the BrowserSync reload and does nothing else. This way we can reload our application when we change any of the HTML or JS files. We're going to hook up our source files to a Gulp watcher and then pass in the reload task as a dependency which will be run when any of the files change. When an HTML or a JS file changes, we're just going to reload our application. And when a SASS file changes, we're going to run the SASS task instead. Finally, we'll add another watcher, this time for our SASS task. We'll also pass in the reload in the SASS task we created earlier, so we can reload our CSS in the browser automatically. That's also why we're using the stream property here to reload. We'll also pass the watch dependency to the serve task so that when we start our server, it's going to watch for changes automatically. We'll just check if everything works as intended, make sure your server is running first and foremost, and restart the task if needed. Then let's change some HTML and some SASS and see if things live reload like they should. Alright, looks like that works just fine. And finally, we're going to add the serve task to our default Gulp task so that we just have to type Gulp instead of Gulp serve, which is going to make our lives a little easier. In this video lesson, we've set up our development environment so that we can get started working on the actual code. In the next section, we're going to start building our supporting services. Those are going to serve as the foundation for our application. This is the first video of section 3 on constructing the supporting services. In this video, we're going to take a look at setting up AngularJS and bootstrapping our application. We're going to use localStorage to store data for some persistence in our application. HTML5 local storage is a way of storing data in the user's browsers so that we can use that data later when they come back to the application. Think of data like favorite animals, past matches, and so on. This way our app will be a little cooler by remembering all the things that happened before whenever we visit the application. So, to get started, we're going to first add AngularJS to Bower so we can use the framework. We'll also install an additional module to handle interfacing with local storage. Let's use Bower to install Angular and Angular localStorage. Let's go ahead and add a main bootstrap file. Let's call it app.js in the source and then scripts folder. We can go ahead and delete the JSHint check file since we don't need it anymore. In the bootstrap file, we're going to initiate our Angular module. Let's call it packed. Since we're going to write our storage service, we're going to prepare it by creating the empty service in a services folder inside scripts. Just leave it empty for now, we're not going to add code to it right away. Let's make sure to add all our dependencies and source files to the index.html to reference the scripts. First, we're going to add our source scripts, so scripts app.js and scripts services storage.js. Now, you might have already noticed that I made a mistake here. I forgot to let Bower know where it should install the dependencies, so it's installed them in the root folder of the project. We don't really want that, so what we'll do is create a quick .bower.rc file in the root folder, and then add the directory property to it. Let's use source bower_components. Now run Bower install again to make sure the dependencies turn up in the right place, and feel free to delete the old folder. Alright, now that that's fixed, we're going to add the vendor dependencies to our HTML as well. Make sure to add them before your own scripts and make sure Angular is on top so that the Angular local storage module is loaded and can use Angular. And finally, we're going to let Angular know that it needs to load the packed module when the app starts. So we're going to add the attribute ng app to the HTML element. Let's use the Angular localStorage module in our application to abstract away the actual storage logic. Let's open up our app.js file, and first we're going to add the module's name to our app modules dependencies, which is localStorage module. Next up, we're going to perform an optional but recommended step. We're going to add a prefix to our stored data to make sure it doesn't interfere with any other local storage data that could be present on this domain, but has nothing to do with our application. So let's go ahead and open up our config block for the module. Let's inject the local storage service provider and then use it to set the prefix. I'm going to choose backed here. Alright, now we're getting to the good stuff. Let's go and open our storage service file again. We'll just create the service real quick. Let's call it storage. That'll do fine. Make sure to also inject the local storage service and then add two methods. One is going to save the data and one is going to load it. Saving the data requires both a key and a value. So we're going to use local storage service here and then set it using the key and set the data. And loading it only requires the key, obviously. And we'll just return the data we get from local storage service.get using the key provided. This concludes the work on the storage service. Using this service, we can add some persistence to our sample application to make it a little more interesting. In the next video, we'll be adding all the required data to our application. Welcome to the second video of section 3 on constructing the supporting services. In this video, we're going to be adding data to the application. We're going to have two data services, one for the animals in our application and one for the terrains. These are going to be really basic services, implementing only a couple of methods. We're going to use a test-first approach to make sure our code works like it should. Alright, so the first thing we're going to do is add Angular mocks to our project so we can start testing our code. The AngularJS mocks module provides support to inject and mock Angular modules into unit tests. Let's use Bower to install Angular-mocks. Next, we'll add this dependency along with all the other Bower components to our Karma configuration file as well. This way, Karma knows which libraries to load, otherwise our tests would fail anyway. Make sure to add all three dependencies, so AngularJS, Angular local storage, and Angular mocks. We'll also have to make a quick adjustment here and only explicitly use just our source script for the tests. Otherwise, it would load the script from the Bower components folder as well due to our globbing pattern. So let's go ahead and change that to source scripts and then use the globbing pattern for the JavaScript files. Let's add our animal data to a constant. We're going to create a new file in a new directory called constants. This file is going to be called animals collection. Conventionally, constants are named using all caps, so we'll do just that. We'll name our constant animals_collection. You don't have to type all this data yourself, you can just find it in the code. You can go ahead and copy paste that. Let's also create our empty animal service before writing the test spec. We'll add it to the services directory and call it animals.js. We'll instantiate the service, but don't add any code to it just yet. The only thing I'm going to do is inject the animals collection and then set up a reference to the service. This animal service has to do two things. It has to either find all of the animals or a specific one. Later on, we're going to expand this functionality even more. So let's create a test suite to make sure our code will work as intended. Let's create one big suite for the entire service first. Let's call it animals, just like the service. Okay, before we can start testing, we're going to need to tell Angular to inject our application because it doesn't know to bootstrap it otherwise. And then add the module packed. We'll add a suite per category, so let's call the first one finding all animals, and the second one finding a specific animal. A suite is basically a way of grouping related tests together. In the first test, it should just return all the animals in the collection, so we'll check if the length is above 0. In the second and third test, we're going to test our code for finding a specific animal. When an ID is given, it should return that existing animal. Make sure to inject the animal service in the function, and then we'll just check if the animal that we find, let's use silverback gorilla here, is actually found and exists. If an ID is given that is not present in the collection, we obviously expect the animal to be undefined. Again, let's inject the animal service and then find an animal that shouldn't exist. Let's use I don't exist, for example, and then we should verify that it doesn't exist. Let's run our tests. And there we go. We have 3 red tests. Let's make them turn green and pass. Okay, open up the animal service, and first of all, let's make sure we've injected the animals collection constant. I've done that already, as you can see. The find all function is really easy since we just need to return the collection we added to our constant earlier. The reason we use a method for this is that we might want to add some more logic to it later on. Next up is the find function to find the specific animal. We'll pass in an animal ID and then loop the collection until an animal is found. So let's just loop the animals collection here. If it's found, we'll return that animal. If no animal is found, we'll return undefined instead. Let's run our tests again to make sure our code works like it should. And there we go, they're all green. Now let's go ahead and do the same thing for the terrains. We'll create a new file in the constants folder. This time we're going to call it terrains collection. Just like with the animals, paste in the terrain data you can find in the code folder, and that's it for this file. Let's add a new service file called terrains. Instantiate the service, but leave it empty again for now. We'll write our tests first. Again, the only thing I'm going to do is inject the terrains collection and save the reference to the service. Like we did with the animal service, we're going to create a small test file to test the functionality of our service. The functionality is the exact same, so go ahead and copy the animals tests and adjust the names so they fit our tests for the terrain. Make sure to get every reference in here, so animals and animal. Also, don't forget about the ID, the silverback gorilla one. We'll do the same thing for our terrain service and copy over the functionality from the animal service. Again, just make sure to adjust all the names and references from animal to terrain. Let's run the tests again, and they should all pass. Alright, awesome. Looks like we're done. In this section, we've implemented basic services that are going to handle loading the application's data. In the next section, we're going to start building out the core of the application, which is the arena. This is the first video of section 4 on building the arena. In this video, we're going to generate the matchup that is going to contain both a random animal and a terrain. The first thing we'll do is writing methods for getting a random animal and terrain. Afterwards, we're going to write a spec to make sure our matchup generator works as intended. And lastly, we'll implement the matchup generating method using our test spec as a reference. Okay, let's get started by jumping straight into the animal service and then adding a new method called getRandomAnimal. This method is going to retrieve a random animal from our animals collection. We'll do this by accessing the animals collection and then randomizing the index, which is just done through math_random and then flooring it and getting the array's length. This is to make sure we don't go out of the array's bounds and that we always get an animal. Next up is the terrain service. We'll implement the exact same method here. You can just copy paste it. Make sure to change any animals references to terrains instead. Alright, looks good. We can't really write tests for this since the outcome is always random anyway. However, since this is pretty much a single line of code that has such a simple and singular purpose, we don't really need a test anyway. Now that that's done, we're going to combine these two methods to generate a random arena matchup. Let's go back to our test directory and create a new file for our arena service, which we'll create in just a bit. Let's call the test arena.js and then house it in the services directory. First, we're going to have to write some boilerplate code to set up our test correctly, and then we're off, just like last time. What this matchup generator returns is random, so we're just going to check to make sure that the things that we want are defined instead of checking for a specific value. Also, don't forget to inject the arena service here, and we'll just create a variable called matchup, which is going to hold the matchup generated by the arena service. So it should return an object that contains both a random opponent animal and the randomly selected terrain. Alright, let's implement it and then combine the methods we created earlier. We're going to create our file first in the source scripts services folder. Let's add a new service called arena.js. Declare the service on the packed module, inject both the animals and terrain services. We'll add the method to our service. Remember, it was called generateMatchup. Let's create two variables, one called opponent will get a random animal from the animal service to fight against, and the other variable called terrain will determine where we'll be having this fight. Now it looks like I made a sloppy mistake here. I actually forgot to rename the method's name from getRandomAnimal to getRandomTerrain. So let's go back to the terrain service and fix that real quick. Finally, return an object containing both our generated opponent and terrain. Let's run the tests to make sure that everything works as intended. And voila, we have our matchup. Now that we have our matchup generator, we can start calculating scores for the animal and the terrain. That's exactly what we're going to do in the next video. See you there. Welcome to the second video of section 4 on building the arena. In this video, we're going to take a look at how to implement the algorithm to determine an animal's total score based on its own stats and the stats of the terrain. First, we're going to calculate an animal's combat score. Afterwards, we'll determine what the influence is of the terrain on the animal. And lastly, we're going to combine those two calculations to get a total score. The winner is going to be determined based on that score. Let's start by opening our arena test file and creating a new test suite for our scoring algorithms. We're going to add 3 tests here. One for calculating the combat score for an animal, one for calculating the terrain's influence on that animal, and finally, one for calculating the final score of an animal based on its stats and the terrain. Leave these tests blank for now, we're going to get back to them in just a second. Let's inject a couple of animals and a terrain into our testing suite to make things easier to test. We're going to open up a before each block, inject the animals and terrain service, and we'll use those to retrieve the rhino, the alligator, and finally the swamp. We're going to assign these to the this object, which will allow us to access them inside the actual tests. Okay, let's go back to our tests. To keep things simple, we're going to calculate a combat score that goes from, let's say, 0 to 10 points. Let's create a combat score variable that contains the combat score for the rhino. Now we'll test for the combat score value and make sure that it is greater than or equal to 0. We'll also chain another test condition, which will be that the combat score can only be less than or equal to 10. Now that we've got our test spec for the combat scoring algorithm, let's go back to the source code of the Arena service and implement it. Keep in mind that this is a really basic app, and as such, there won't be any super complex algorithms at play here. First, to make things a little more interesting, let's create some stat weights on top of the file that we can tweak later. Let's favor ferocity by downscaling tenacity just a little bit to 0.8. Next up, create the calculate combat score method that we used in our test. This method takes one argument, namely the animal to calculate the score for. We'll just multiply the animal's ferocity and tenacity with their respective stat weights, and then get the average of that number by dividing it by 2. Let's go back to our test file real quick and then fill in the stub for this second test. So let's just create a variable called terrain influence and then use the Arena service. And let's call the method calculate terrain influence. Let's pass in the rhino and the swamp. It's practically the same test as the combat score, only this time we want the terrain's influence to be between 0 and 1. Again, these algorithms aren't super complicated, so we'll implement a really basic terrain influence scoring mechanism. Go back to the Arena service and add the calculate terrain influence method. I'm just going to go back to the test real quick and copy the method's name. Alright. And it should take an animal and a terrain. Let's calculate the influence for land and water separately. Let's multiply the animal's land stat with a percentage of the terrain's land stat. We'll do the same thing for the water stat. Finally, return the sum of both stats divided by 20 to get a number between 0 and 1, which is going to act as a percentage. Alright, here we are. The end is in sight. Let's calculate the total score. Go back to the test file again and fill in the stub. Let's calculate the total score for the rhino inside the swamp. Let's call the method calculate total score. Since our combat score is a number between 0 and 10, and is multiplied by the terrain influence that is scored between 0 and 1, so a percentage, it's only logical that this final score will also be a number between 0 and 10. Let's go back to the source file of the Arena service. This method is really easy since we just have to use the other two methods we just created. First, get the animal's combat score, and then get the terrain's influence. We'll just use the method we created earlier and pass in the animal and also the terrain. That's going to tell us how well this animal would perform on this terrain. Multiply the combat score by the terrain influence, and presto, we have our total score. Let's open up a terminal and run our tests to make sure that everything works. Okay, looks good. So just a quick recap. In this video, we've calculated an animal's combat score. We've also calculated a terrain's influence on an animal. And then we've combined both scores to calculate a total score for that animal. Now that we've successfully done that, we can move on to the next video in which we'll fight the match and then determine the outcome. This is the final video of section 4 on building the arena. In this video, we're going to use the methods we created in the earlier section to determine the winner. First, like always, we're going to write a small spec to figure out what the method has to do, and to verify that it works as intended. After writing the spec, we're going to implement the method until it passes the tests. Lastly, we'll save the match results to storage so we can show the match list in our app later. Let's open up our Arena test file. We'll create a new test suite for determining a winner. Since we want to test with real data, let's copy over the before each block in the previous suite. That's going to make our life a lot easier. In this suite, we're going to have two tests. One that checks for a winner in a non-equal matchup, and 1 to make sure there's a draw outcome when the matchup is equal. So let's go ahead and create that test. It should determine a draw if the matchup is equal. Let's determine the outcome of the first test by choosing the alligator for ourselves. We'll fight against the rhino, and as a terrain we're going to use the swamp. Since our alligator is more at home in swampy areas, we should win from the rhino in this matchup. So this outcome should equal player. For the draw, we'll pitch 2 rhinos against each other, again in the swamp. This time the outcome should obviously be a draw. Now that we've got our test set up, let's go back to the source file for the arena service and create a new method called determineWinner. Before we start determining the winner, we'll need to adjust an algorithm, namely the terrain influence 1. The one we set up in the last video needs some more tweaking, so let's change it up here, which will make our results more predictable and realistic. So we're going to multiply the animal stats with the terrain stats and then divide it by 10. This method takes 3 arguments, which are in order the player's animal, the opponent's animal, and then finally the terrain on which the map will be played. We'll use our methods we created earlier to calculate the animal scores. Let's calculate the player score variable and the opponent score variable. So I'm just gonna copy paste it and then change it to opponent. Let's also create an outcome variable that will hold the outcome of the match. First of all, if the player's score is equal to the opponent's score, it's a draw. So we're going to check for that first and then set the outcome. If it's not, we're going to check if the player's score is higher than the opponent's score. If it is, the player will have won, and otherwise the opponent wins the match. And then finally, just return the outcome. Let's run our tests to make sure it works as intended. Alright, looks good. Let's move on to storing the match result. First of all, we're going to need to load the previously played matches. To do so, we'll inject our storage service we created earlier and then simply load the matches key. Or if it doesn't exist, default to an empty array. Next, we'll add an entry to the played matches by pushing an object into the array. This object is going to contain the player's animal ID, the opponent's animal ID, the terrain ID, and lastly, the outcome. We're going to store these so we can use them in the view later to show previous matches. Lastly, we're going to persist these played matches to our storage again, so just save it using the matches key again. Alright, that's it for the meaty part of the arena. What we've done so far is writing a test spec for determining the winner. We've actually implemented the method for determining who won the match. And finally, we've saved the matches to storage, which we can use later to display in the application. In the next video, we're going to hook up all this stuff to the controllers and views to create the application. This is the first video of section 5 on developing the application. In this video, we're going to use all the logic we created earlier to display a matchup to a user. Firstly, we'll add Angular UI Router to our project so we can add routing to our application. Angular UI Router is not the default router, since AngularJS also has a core router, which you still need to install separately anyway. Angular UI Router is a state-based routing system, and also a little more flexible than the default AngularJS router. It might be a little much for this project, but it's good to get some practice in with it regardless. Then we'll scaffold the controller and the view for the arena route, in which we'll be fighting our match. In this section we'll also generate our matchup, which we will use in the following sections to fight the actual match. Okay, so to add Angular UI Router to our project, the first thing we need to do is add it to our project using Bower. So, as you might have guessed, we'll go to our terminal and then install Angular UI Router through Bower. Let's load the file in our HTML as well. So, same thing, that's going to come from the Bower components folder. This time it's going to be called Angular UI Router. And then in the release folder, Select the right file. Now let's go to our app.js module next and add it to our Angular modules dependencies. The module is called UI.router. We'll also go to our index.html and replace the body content with the UI view directive. This way we can load views using Angular UI router. Next up, let's create the arena state. We'll go to the config block and inject the state provider and URL router provider dependencies. So this should be URL router provider. First, we'll make sure our application defaults to the root route, which will be the dashboard, which is located at the / path. Now, let's create our state using the state provider service. We'll call the state arena and also with the same URL /arena. Pass in the URL of the template that we'll create in just a second, which is scripts partials arena.html. We'll use the controller as syntax with the controller name being arena. Lastly, we're going to pass in the name of the controller we're going to create in just a moment. Now that we've got our state set up, let's go ahead and create a controller in the controllers directory. Let's call it arena.js. We'll create a basic controller with nothing in it yet. So packed module, controller, and the name is arena control. Let's also create an HTML file in the partials directory and call it arena.html. The same name as the template URL we passed into the state just a moment ago. Okay, let's generate the matchup containing the opponent animal and the terrain. Let's go back to our arena controller and pass in the arena and timeout services as dependencies. We're going to use the timeout service to set a small delay when generating the match, and this way we can show some kind of spinner or loading animation while it's generating. This way we're going to give the illusion that we're actually generating the match. Since we use the controller as syntax, we'll follow Angular conventions and create a VM variable that holds the reference to this, meaning the controller. Let's create a timeout of around 2 seconds, after which we're going to generate the matchup and add it to the controller. We're going to use our arena service method here called generateMatchup. There we go. And a delay of 2 seconds. Now that we've got our matchup generated in the controller, we're going to show it in the view. Let's create a small loader element that only shows when the matchup doesn't exist yet. So I'm just going to add a div with the class loader and say something like generating matchup, I guess, and only show it if there is no matchup found. Next up, we'll show the matchup when it has been generated. So I'm just going to copy this and then remove the loader class and only show it when it does have arena matchup. For debugging purposes, we'll just render the matchup in a pre-tag to verify that it's been added to the view correctly. We'll just worry about the presentation later. We're also going to add a JSON filter to it so we can format our data, which is going to make it easier for us to view. Make sure we add all the files we need to our index.html as well. So let's add the constants first. So the animals collection and also the terrain collection afterwards. Next up is the animal service and also the terrain service. And then we're going to add the arena service. And finally, our controller. Let's move to our application and visit the arena route. Okay, after 2 seconds, it generates a matchup and then shows it in the view. In the meanwhile, it shows us the loading element like we wanted it to. Alright, cool. In this section, we've added an arena state to our project using Angular UI router. We've created an arena controller and view, and finally, we generated a matchup using our earlier service logic to show it in the view. Next up is creating the animal and terrain card directives so we can present our animals and terrain in a nice, reusable way. This is the second video of section 5 on developing the application. In this video, we'll take a look at how we can create reusable components for our application using directives. We'll do this for both the animal and the terrain. We're going to create directives that contain the presentational logic so we can easily call upon these directives later. First, we'll create a new JavaScript file to contain our directive in. Let's create a new folder in our scripts folder called directives. In that folder, add a new one called animal card, and then in that folder, add a file called animalcard.js. So in this file, we'll just add a new directive to our Angular module and call it animalcard. Beware of the camel casing. We're going to create a new scope where we pass in the animal data. We'll use the directive's attribute name to pass in the data and then rename it to the animal property. Next up, we're going to add a template to the directive. Make sure you specify the right path and then create the HTML file. So directives animalcard.html. Speaking of which, let's create it now. All right. In this HTML file, we're going to create a div with a couple of classes. In here, we're going to add a couple of elements to the card as well, like the animal's photo, its name, and its statistics. So let's add the ngSource attribute first to prevent the image from not showing up properly. And we'll say images/animalid.png. That's where we'll store the images. Next up is the name, so just pass in the animal's name. And finally, we'll open up a stats list showing the animal stats. So that's stats.ferocity, and then add the ferocity label, and do the same thing for tenacity as well. The terrain card is almost identical to the animal card with some minor differences. Seeing as they're so similar, let's go ahead and copy the entire animal card directive folder and then call it terrain card instead. Take care to rename the JS and the HTML file to terrain card 2. Let's go into the JS file first and rename all of the references of animal to terrain. Be sure to change the template's URL as well. Next up, let's go into our terrain card directive HTML and change the references to animal there too. So let's go ahead and select all the animal occurrences and replace it with terrain. In this list, we only need to show the terrain stats for land and water, since the terrain obviously doesn't have any tenacity or ferocity. Finally, let's use the directives we just created in our application. First of all, let's add the JavaScript files for the directives to the HTML. So both the animal card JS and also the terrain card JS as well. Then go back to the arena partial and add both the animal and terrain card directives to the matchup, and also passing in their relevant data. So I'm just going to duplicate this and then change the animal to terrain. Alright. Go to the application in the browser and presto, our directives are being shown like they should. Awesome. The presentation is really basic and the images don't load yet, but you can go wild here and create your own sorts of cards and styling here. That's totally up to you to decide. Okay, that's it for this section. We've successfully created our animal and terrain card directives, so we can easily represent them in the application. In the next video, we'll create an animal picker so that we can find a match with our animal of choice. This is the third video of section 5 on developing the application. In this video, we will generate a grid with animals to select our own animal and then find the match with it. In short, that means adding an animal grid directive, then adding the logic to select an animal to fight with, and then finding the match and showing the outcome. First, we'll create a small grid containing all animals. We can then choose an animal from this list to find the match with. Let's start by creating a new directive in the directives folder. Just like last time, we create a new directory with the directive's name. In this case, that's animal grid. Create a JavaScript file with the same name in this directory. In this file, we'll declare our directive first. Let's call it animal grid. Again, keep the camel casing in mind. Pass in the template's URL. We'll create the template in just a second. And the URL is scripts/directives/animalgrid/animalgrid.html. We don't need a controller here since this directive just serves as a template. Let's add that template we just declared. In the animal grid directive folder, let's add an animalgrid.html file. In this directive, we'll add a basic list with the animal's name. We'll add a repeat on the arena.allAnimals property, which we'll add to our controller in just a second. And for the content of the element, we're just going to add the animal's name for now. Alright. Okay, back in the arena controller, we need a list of all the animals for the grid directive. Let's add our animal service and then add the animals collection to our controller. We'll do this by using the findAll method we created in one of the previous sections. Now that we've got a grid of all the animals available to us, let's add the logic to actually select the animal. We'll add two functions to our arena controller. The first one selects the animal by passing it to the controller, which then sets the player's animal on the scope. Next, we'll add a method to check if an animal in the grid is the selected one. This will allow us to highlight the animal in the grid to show our current selection. So first we'll check if there is actually a player animal selected, and if there is, let's check if the ID of the selected animal matches the ID of the animal passed into the function. And finally, we're going to expand our animal grid template with the new stuff we just built in the arena controller. Let's open up the animalgrid.html file again. We'll add a click handler to select the animal inside the ng-repeat, and also add a selected class if the animal is the selected one. So ng-click fires off the selectAnimal function in our controller, and class is just going to add selected if it is the selected animal. And lastly, let's format the HTML so it becomes a little more readable. If I have a lot of attributes, I like to put them on a different line each. Makes it easier to read. And then I'm just going to add this on a new line as well. Okay, great. Now that we have an animal we can find the match with, again in our arena controller, we'll add a new method to find the match. All we need to do is use our arena service method and pass in all the relevant arguments. So vm.matchWinner is arena.determineWinner. In order, they are the player animal, the opponent's animal, and finally the terrain in which we'll be fighting. So let's go back to our view. Alright. Then let's add a new section. We're going to add a title saying choose your animal, and in here we're going to add our animal grid directive. Okay. Next up is sort of like a hinting phrase for the player to see what he's fighting against and which animal he has chosen. So let's just say you're fighting as a, and then the name of the animal, against a, and then the opponent, and then also the name of that animal. Let's also include the terrain just to make sure they know everything there is to need to know. Okay. Let's format it. Okay, looks good. Now let's add a button to trigger the actual fight. So let's say ng-click arena.fightMatch. Add a label as well. Let's call it fight match. Okay, let's make sure animal grid doesn't show if there is a match winner. And we should show something else if there is a match winner to show the outcome to the user, if they won, lost, or if there is a draw. Now that we've linked our button to triggering the match fight and we have the outcome, let's show the winner in the template too. Keep in mind that there are three scenarios. The player either wins, the opponent wins, or the match was a draw. Okay, let's go back to our index.html and add all the scripts we just created. So animal grid, animalgrid.js. Make sure it's loaded. And there we go. We get an animal grid saying choose your animal. Let's select an animal, find the match. Alright, it just shows the match outcome now, which is what we want. Let's go back and add some additional functionality. I'd like to reset the match after one has been played so you can play again easily. Let's add a button here. Add the ng-click directive. And let's say arena.resetMatch. That's a function we're going to create in just a second. Let's add some text to the button. Play again should do it for now. Let's go back to our arena controller. Alright. First thing we're going to do is create our function for resetting the match. So let's take all this and cut it. And we're going to wrap it inside a function. Let's call it generateMatchup. Alright, just paste in the code. and then execute it straight away so that we can generate a match when the controller is first instantiated. Let's create a new method on the scope called resetMatch. And when that's clicked, we are going to clear the matchup. Let's just set it to undefined. Let's do the same thing for the match winner as well. And lastly, we're going to generate a new matchup. Okay. Now let's see if it works. Let's choose an animal, find the match. Alright, now we have a button, play again, let's click it, and there we go, it generates a new matchup for us to play. Okay, perfect. We've successfully linked all functionality together for the arena view. We've added an animal grid that makes it easy to select an animal to fight with. And lastly, we've triggered the match to be fought and then showed the outcome. The last part in this section will be adding a small dashboard view with some metadata information. This is the final video of section 5 on developing the application. In this video, we will be using metadata generated after fighting a match to show in the dashboard view. First, like we did with the other view, we're going to scaffold the controller and the view. Afterwards, we'll slightly modify our arena service to add a bit of metadata to our application. And finally, we'll be using that metadata to display in the dashboard view. Before we begin working on the dashboard, we're going to need a state for it first. Let's open up the app.js file so we can add a new state to it. Let's call the state dashboard and give it the root URL, so that's just a /. Add in the dashboard template, which we'll create in just a moment, along with its controller information. Just like in the arena view, we're going to use the controller as syntax. In this case, we'll call the controller dashboard. Now that we've got our state set up properly, let's create our controller and our partial. In the controllers directory, create a new controller called dashboard. I'm just going to scaffold it. Let's add it to the packed module. Create a new controller. Let's call it dashboard control like we did in the state. Inject the arena service as well. And then just set up the view model variable. And let's also create a dashboard partial in the partials directory. Let's add some additional functionality to our services for the dashboard metadata. So let's go ahead and add our first method. Let's call it getPlayedMatches. This function is just going to return our played matches we've stored so far. Next up, let's duplicate the played matches variable and call it favorite animals instead. Let's load the favorites from the storage and default to an empty object. It's going to be mapped to the animal's ID. Let's go ahead and copy our getPlayedMatches function. Let's call it getFavoriteAnimals instead. There we go. And just return the favorite animals like we did with the played matches. Now you might have noticed that we don't have any favorite animals data yet, so let's go ahead and fix that. Let's go to the bottom of the file where we fight the match and determine the winner. So first we're going to check if the favorite animal is stored in our favorite animals map yet. So it's based on the player animal and then the animal's ID. And if it's not there, we're just going to set it to 1 instead, because that means the favorite animal has been played for the first time. So again, just pass in the ID of the animal and set it to 1. Otherwise, if it does exist, we're just going to increment the count. Okay. And finally, let's also save our favorites in storage. So favorites and then favorite animals. So let's go ahead and open our dashboard controller again. And the first variable for the view is going to be played matches, which is just gotten through the arena service, and then get played matches. Okay. Now, as you remember, our data structure is a little different, so we're going to have to map it because it only has the ID. So we're going to inject the animals and terrain service, and then we're going to return a new object based on those IDs. So we're going to return an object with the player animal. Okay, so that's animals.find and then match.player. Remember, it only stored the ID, so we're using the find functions here to get the full information. Do the same thing for the opponent and then also for the terrain, but take care to use the terrain service for that. And then the winner is just the match winner. Alright. Let's also add the favorite animals to our view. So vm.favorite animals to our view. So vm.favorite animals is arena.getFavorite animals. And remember, that's also just an object with the ID and the count, so we're going to have to do some trickery to get it to display properly in the view. So we're just going to inject the animal service inside the view as well. Let's open up our dashboard. Create a new header called previously played matches, and then we'll just open up a list. And then repeat over the matches. So dashboard.played matches. Alright. And then we'll just say the player's animal name versus the opponent's animal name. Let's just copy this. Alright. And then finally show the winner. Let's open up our index and also take care to inject the controller we just created, so the dashboard controller. Let's go ahead and open our application. Alright, it does what it should. It shows us a list of previously played matches. Let's go back to our dashboard view and then add a new title called Favorite Animals. We're just going to open up a list again. This time we're going to loop over an object, so we're going to use the animals key and the count value in the dashboard.favorite animals. And since we only have the animals ID here too, we're just going to use the animal service, so dashboard.animals.find, and then the animal, which is the animal ID, and then pass in its name, and then we'll just show the count. Let's open up our app again, and there we go, favorite animals. It shows us which animals we've played the most. Okay, that's it. We now have a basic dashboard that shows our previous activity in the application. Now that we've successfully completed our application, we can start finishing our build system and deploying it to Heroku. This is the first video of section 6 on deploying to Heroku. Heroku is a cloud application platform allowing us to easily deploy our application to the web and scale it according to our needs. Heroku allows us to focus on writing code instead of worrying about server infrastructure. In this video, we're going to add a monitoring tool to keep track of any errors that might occur in the application. We'll use Bugsnag for tracking errors in our application. The Bugsnag notifier for JavaScript gives you instant notification of errors and exceptions in your website's JavaScript code. We can then use this information to fix any issues that might arise when users use our application. You'll obviously need to create a Bugsnag account, but don't worry, that's completely free. When that's done, come back to the video and we'll get started by integrating it into our project. Since AngularJS has some custom errors that don't show up automatically in Bugsnag, we'll create an error handler for those errors too. Okay, first let's create a project in Bugsnag, making sure to select AngularJS. When a project's created, you'll end up on this page that shows you how to integrate it into the application. Copy the script tag and paste it in our HTML template inside the head element. And afterwards, we'll add the AngularJS exception handler to the code that you can also find in the Integrate Your Application page. Let's go ahead and add this to our app.js file. Next, let's force an error in our application by injecting a dependency that doesn't exist. Let's use foo. Refresh the application to make sure the error is triggered, and then go to the Bugsnag dashboard and refresh to see the error. This way we can easily debug our application if users experience any errors in our app. Make sure to also remove the foo injection from the app to avoid any future errors. Okay, this was a super quick video on using Bugsnag to track errors. The next video will be a little longer, in which we'll create a production build that uses minified assets. This is the second video of section 6 on deploying to Heroku. In this video, we're going to create a production version of our application, which we'll use to deploy to Heroku in the next video. We'll start by bundling all our JS files. Afterwards, we'll optimize the CSS for production and then create a dist version of our application that we're going to serve to the users. Alright, let's get started. The first thing we're going to do is replace all of our script tags with just 2 scripts instead. Bundle.js, which is going to have all of our source code, and then vendor.js, which will include all minified vendor dependencies. To do that, we're going to use a Gulp plugin called Gulp HTML Replace. This Gulp plugin will allow us to automatically replace all references to scripts within a certain build tag, which you'll see in just a minute, to one reference instead. This way we can use the separate files during development and automatically create script references to the bundled script when we create a production version. So let's install it using npm. So npm save gulp-html-replace. In our HTML, we'll add build tags surrounding our scripts. So for the vendor files, we'll add a build tag called vendor, which you open with an HTML command and then build : and then the tag's name. Alright. Now we're going to add one for the source files as well. Let's call it source. Alright, and now we just need to close the tag as well, the build tag. So we're just going to add another command saying unbuild. And we'll do the same thing for our source files. Next, we'll add a gulp task to process our file and save it in the dist folder. Again, the dist folder will be used for our production version for the application. So let's call the task HTML replace. First, we're going to add it to our plugins in the gulp file. So just open up a new variable. Let's call it HTML replace. Now let's use our index.html as the input file. So we're just going to take it from the source directory and then index.html. Then we're going to pipe in the HTML replace plugin. And the options we give are the tag names we added earlier, so vendor, which we will then bundle into one file called vendor.js inside the scripts folder. We're going to do the same thing for the source files as well. Alright. And then just finally pipe it to its destination, so the index.html inside the dist folder. Next up is bundling the files into the new files we just specified in the HTML replace plugin. We'll use gulp concat to do just that. So install it by typing npm install --save gulp-concat in the terminal. Once it's installed, add it to our gulp file. We'll create two tasks here, bundle source and bundle vendor. Let's start with the bundle source one. Let's add it to our variables again. So concat, that's the concat plugin we need. All right. Now let's add our source files, which is all the JavaScript files. So we're going to add the scripts app.js first, and then the rest. We need to add app.js first because it's our module definition and that needs to be loaded first. Okay, then pipe in the concat plugin. We're going to rename the file to bundle.js. And then finally save it to the destination, which is going to be dist and then scripts. Okay, next up are the vendor files. Since the Bower components already have a minified version available, we'll just use those and add it to one file called vendor.js. So add in all the vendor dependencies we need to the stream. First, we're going to add Angular. Just going to inject it here from the Bower components folder and just take angular.min.js. Make sure to select the minified file. We're going to do the same thing for Angular localStorage in the dist folder and then Angular localstorage.min.js. And finally, do the same thing for Angular UI router, which is in the release folder. Alright, and then select the minified one again. That should do it. Concatenate them again, and then save it to a file called vendor.js. Also in the dist/scripts folder. Okay, let's run the three tasks we just created to verify that they work like we want them to. Run the HTML replace task first and go check out the new index.html file in the dist folder. It should have replaced all of our script tags with the ones we specified in the task instead. Next up, run gulp bundle source and bundle vendor to run both of our bundle tasks. Let's check out the scripts folder in the dist folder, and here we are. Both files are present and contain the code that they should. The bundle file contains all of our application code in one file, and the vendor file contains all of the minified vendor code we need to run our app. Let's add the dist folder to our git ignore since we generally don't want to commit our compiled application. We'll build the application on the server instead. Since we want to keep our production code as small as possible, we'll also annotate and uglify our AngularJS code. We need to annotate it so that AngularJS's dependency injection system doesn't break when we minify the code. AngularJS figures out which dependencies to inject based on the parameter names in the functions, for example, a controller function. However, since the parameter names will be changed when we uglify the code, our application won't work anymore. You can fix this by manually annotating your functions with the array syntax, in which you define your dependencies both as a string and then again as a parameter. To avoid doing such tedious work, we'll use a Gulp plugin to do that for us. So install the annotate and uglify plugins by installing them with npm. They're called Gulp annotate and Gulp uglify. Add the modules to our Gulp file. So that's annotate, then require it, and do the same thing for uglify as well. Alright, there we go. And then we'll just pipe those into the stream for the source bundle file, and that's it. Let's run the bundle source task again to verify that we now have a minified file. And there we go. It has properly annotated our code as well, as you can see. In a production version of the app, we'd like to keep all of our extra server requests to a minimum. This is why instead of letting AngularJS load the HTML partials by requesting them from the server, we're going to add them to the template cache instead. That way, all the required templates will be added to our source code in JavaScript, and we won't have to load them externally anymore. We'll have to install two dependencies here, one called Gulp Angular Template Cache and one for Event Stream. We use Event Stream to merge the source files and the template cache file so that we don't need to write an intermediate file to the disk while building. So let's add Event Stream and also Angular Template Cache as plugins here in the file. So let's create a merged stream by returning the ESMerge function and then adding our two separate streams. The first stream is going to be the templates one. To compile our templates, we'll add all the HTML files in our project to the Gulp stream and then pass in two options. The first one is the module's name, in our case that's packed, and the other option is a root one to make sure that the paths in the template cache are correct. In our case, that's the scripts folder. Next up, we'll just add the source files like we did earlier. And finally, transform the stream by piping in the concat plugin and then writing it to disk. Let's check if it actually added our templates to the templates cache. Remove the uglify plugin temporarily so we can easily look through our compiled code. Open up the bundle file and you'll see that it now has the template stored inside the template cache. You might have to scroll a bit to find it. Now don't forget to go back and add the uglify plugin again. Lastly, we'll need to copy our CSS styles too. Let's create a new task that takes the app.css file and writes it to the styles directory in our dist folder. So let's add the CSS file first, which is in source and then styles, and it's called app.css. And then pipe in the Gulp's destination, which is in dist and then styles. Since this task depends on the SASS being compiled, we'll just add the SASS task dependency to our task here. However, we're not completely done yet. Let's add CSS auto-prefixing and optimizing to the mix so that our style sheets are up to snuff. Auto-prefixing our CSS will automatically add vendor dependencies to the CSS properties that need them, allowing us to use CSS properties without thinking about browser-specific syntax. And then lastly, the CSS optimization will make sure to delete any comments, whitespace, and so on, sort of like an uglify but for CSS instead. Let's install both plugins by using npm again, save both Gulp auto-prefixer and Gulp CSSO. Let's add both plugins to our Gulp file, So the first one is auto prefixer, and then the second one is CSSO. All right. And then add them to the stream in the styles task. And that's it. We're done. Let's run the task to verify its output. There we go. We have an optimized minified CSS file. Now that we've got all of our tasks set up, let's create a build task alias that runs all the tasks we just created. So those tasks in order are HTML replace, then bundle source, bundle vendor, and finally copy styles. Since we have to make sure that our production version works as intended, we'll add another serve task that serves up our production version so we can verify that it actually works. Let's copy the serve task, replace the name with serve dist, and set the base directory to dist. Okay, let's go ahead and open terminal and then build the actual application, the dist version. Let's wait a minute, alright, and then serve it. Let's see, looks like something went wrong unfortunately. Let's just inspect what it is. Looks like the source file isn't found. Alright, let's go back. Check out our index.html, the one that's generated. And it says scripts source.js. So what we've done is added a wrong reference. Source should actually be bundle.js instead of source.js. Let's go ahead and cancel the server and rebuild our application and then serve it again. Let's see what it looks like. Alright, it looks like it works now. Okay, so a quick recap. We've created a production version of our application by replacing the script references, bundling our source and vendor files, caching the templates, and optimizing the CSS. Now that we have all that, we can deploy our application to Heroku in the next video. This is the final video of section 6 on deploying to Heroku. In this video, we're going to create a Heroku application on which we'll host the application we made together. The first thing we'll do is creating the actual Heroku application. Then we'll serve our application using a really basic Express.js server using Node.js. And when that's done, all that's left to do is deploy the application to Heroku. Okay, let's begin by creating our Heroku application. You should have installed the Heroku toolbelt for this course. We'll need that in just a second. If you don't have it, go back to the first section for instructions on setting it up. Let's start by logging into Heroku first using the Heroku login command. Enter your email address and then also your password. Alright. The first thing we'll need is a custom build pack for Heroku. Heroku does have a Node.js build pack, which we'll need, but it doesn't have Gulp installed. That's why we're going to fork the build pack on GitHub from this location. You could also use that repository directly, but the danger of doing so is that the repository might disappear someday. By forking it, we guarantee that our copy is always available to us. So after forking the build pack, we'll copy the repository's URL, which we'll use to create the Heroku application. Go to the terminal and type Heroku create -- build pack, and then the URL to the build pack. Okay, cool. We have our very own Heroku application. Okay, now that that's up and running, let's create a really basic Node.js web server that serves our application. Let's install Express and gzippo using npm. So npm install -- save Express and gzippo. Express is going to act as the web server, while gzippo will take care of serving the static files. Go back to the project and create a new file in the root folder of the project. Let's call it web.js. In this file, we're going to require both Express and gzippo. And then start a basic web server. Create the server by executing the Express module and then add the gzippo middleware to serve our static assets in the dist folder. Lastly, we'll tell the server to start listening on a predefined port, or if there is no port, on port 5000. The reason why we let it run on a predefined port using environment variables is because of Heroku. Heroku determines which port it'll use. If we hardcode a port, we won't be able to serve our application. Now we need a way to tell Heroku to run our server. To do so, let's add a new file to the project root called procfile with a capital P. In this file, we'll tell Heroku to start running the web.js file using Node. And that's it. Since we need to compile all of our production assets on the server, we're going to add a Gulp task alias. Since our environment will be production, we'll add a new Heroku task to the Gulp file. The name of the task is really important since that's part of the custom build pack we're using. It uses the format Heroku, and then the environment, where environment is production in our case. So let's add that task and pass in the build task as a dependency, so that our build is run on every deploy. Since Heroku can magically tell which environment the application is running on, we'll specify that using an environment variable. Let's go back to the terminal and add the environment variable to the Heroku configuration. So Heroku config sed node_env is production. Okay, it looks like we're done, so I'm just going to commit all this. And then we're going to push it to the Heroku master branch. Make sure to push it on the master branch because that's the only branch Heroku will deploy on. So let's push it to the remote Heroku and push the master branch. Then Heroku is going to kick off and start our build process. Okay, it looks like we're done, so let's open up our app by using Heroku open in the terminal. And it should launch a web browser, let's see. Okay, apparently it's not doing what it's supposed to. Let's take a look. It's missing vendor.js. That means that our Bower components haven't installed properly yet. Let's take a look. Okay, we're going to need to save Bower locally as well, so use npm to install and save Bower to the package's dependencies. When that's done, let's open up our package.json file. And in the scripts object, we're going to add a post install script, which is going to fire after npm has installed its own dependencies, so before our build processes. So we're going to add the Bower binary in the node modules folder, and then use that to install Bower's dependencies. Okay, make sure to add everything to Git, make a new commit. Let's say add Bower integration. Alright, post install, that'll do. And now just push it to Heroku master remote again and wait for the build to finish. It might take a while. Okay, looks like it's done. Let's open up the application again using Heroku open. Alright, looks like we fixed the Bower issue and it works as intended now. And the last thing I'm going to do is add a quick link from the dashboard to the arena view. So let's go ahead and open up our dashboard view. Alright. And down below, let's just add a quick link to our arena. So we're going to use an anchor element and then say play a match. And we're going to use Angular UI srev directive to reference the arena view. Let's check it out, see if it works. Alright. We just deployed our first application to Heroku, so give yourself a pat on the back. There's still a bunch of stuff to do, such as creating styles and markup for it and so on, adding links here and there to the various states. However, I'm going to leave that in your, by now, very capable hands. We'll discuss any future steps you can take to take the app to the next level in one of the next sections. This pretty much concludes the course on deploying AngularJS. We've created a basic application, then made sure everything was precompiled and minified for production, and then we've deployed it to Heroku. In the next section, we'll be wrapping up things by providing a quick recap, and any troubleshooting steps for issues you might have. Congrats on a job well done. This is the first video of the final section, section 7 on wrapping it up. In this video, we're quickly going to recap what we've achieved so far and go over some basic reading materials to get even better at Angular development. Alright, now that we've basically completed the course, we can take a look back with pride and see what we've accomplished. The first thing we did was set up our initial development environment, starting with Karma and JSHint integration using Gulp. Afterwards, we served our application using BrowserSync to make developing locally a lot easier. And last but not least, we added SASS compilation to make authoring our CSS a breeze.
Next up was implementing the basic services that would serve as the backbone of our application. We added a service for storage, for generating an arena matchup, and also wrote logic to determine a winner. Lastly, we added some directives to make representing our terrain and animal information. We then deployed all that AngularJS goodness to Heroku to run our application in a production environment. Other people are now able to use our app. Sweet. If you want to learn more about testing and expand it a little further, you can do so by including end-to-end testing as well using the protractor tool. This allows you to not only test the core logic of your application, but the entire application flow, just like you would test it yourself in a browser. The AngularJS docs are a good place to start if you have any doubt about some functionality in AngularJS. And if you want a faster way to browse the docs, you can always use devdocs.io/Angular. And for more concrete courses on Angular, you can go to Egghead or Thinkster, or obviously Unpacked as well. Those are some great resources for learning more about AngularJS. And lastly, AngularJS's community is friendly and huge. If you need any help with anything, you'll be sure to find an answer either on Stack Overflow or in the AngularJS IRC channel on the Freenode server. In the next video, we'll talk about some future steps you can take to make this application even better, along with some basic troubleshooting tips. This is the last video of the final section, section 7, on wrapping it up. In this video, I'll quickly go over some basic Heroku troubleshooting, along with some hints for future steps you can take to bring the application to the next level. If for some reason your Heroku application doesn't start, make sure to scale your dynos on Heroku up to at least 1. You can do this by typing Heroku ps:/scale web is 1 in your terminal. That's going to start the dynos. If you get an error 502 on your Heroku application, make sure you don't explicitly define a port as the first option in your Express.js server. This is because Heroku automatically determines a port to be used by your application. You'll have to make sure your server is listening on that port, so be sure to literally copy that part of the code without any errors or modifications. Also, if your app isn't being built properly using Gulp, make sure you followed all the steps in the build process section earlier, and also make sure you instantiate the Heroku application with the custom Gulp build pack. You can find all of that information in section 6.3. Unfortunately, that is it for this course on deploying AngularJS. Thanks a bunch for coming along for the ride. I hope you've learned something new by the end of it. Remember, practice makes perfect. Go out there and create some cool apps.